One of the biggest security risks ever, the techniques of exploitation is straightforward and lethal. The stack of the program stores the data in order whereby the parameters passed through the functions are stored first, then the return address, then the previous stack pointer, and subsequently the local variables. If the variables, like an arrays or so forth, are passed without boundary checks, they can also be overflowed by sending a large amounts of data, which corrupts the stack, leading to the override of the return address and consequently a segmentation fault. If the trick is craftily done, you can also modify the buffer to point to any location, leading to code execution altogether. Again, it's pretty fun stuff once you can get it working. We also have another term that we use. It's called fuzzing. And basically with fuzzing, it basically allows us to throw to the application random characters and so forth to see how it will act. And then from that, hopefully crash the application, which is also another way of, why we would use a buffer overflow type of attack, is to basically take that and crash the system along with that, which again would be beneficial, of course, for those denial service types of attacks and so forth. And keep in mind too, real quickly, is if you are not using C++ for some reason or not, a lot of the additional types of tools that might be used out there when it comes to programming languages, you will most likely be using Python because that becomes the most popular ones out there that when it comes down to looking at additional things, especially when it has to do with scripting and so forth along with that also. So other than that, pretty straightforward. When you come across any type of buffer overflow type questions, they're going to be pretty straightforward. So just look at the questions and use logic, because a lot of them too, you just look at it and you'll be able to figure out the answer just by looking at the question specifically. So buffer overflows generally are more complicated in the real world, but also very simple when it comes down to it of what they're trying to do. And of course, there are tools out there that will allow us to do all that fun stuff too. Of course, the other section is that you need to educate your users as a countermeasure as well. So it's extremely important to inform end users about the dangers of running software obtained from untrusted sources. And you know that happens. Users go out there, they download, hey, I have smiley faces on my new Outlook, whatever the case may be, right? It happens. So instead of having users simply just read and sign off on the company's computer use policy, actually discuss computer security issues such as picking strong password, malicious software, etc., and so forth in the face-to-face meetings. Remember, there's no patch for ignorance, and we need to keep that in mind. All right, now let's take a look at our last section here, which is going to be cryptography and so forth. So we're going to look at some of the crypto question type scenarios you may be coming across in at least some of the scenarios, and keep in mind that everything I mentioned, you want to make sure you understand a little bit more of. All right. So when it comes down to it, one of the things we're going to look into is symmetric cryptography and hashing and asymmetric. And of course, knowing some of the differences there and so forth. We have talked about a few of these things as we go through, but just know we're going to break this down and take you home from there. All right, and then have you go out there and take that exam, get it out of the way, and hopefully with the videos you've watched here, along with some of the studies you've done on your own, you should do very well on getting that CEH exam passed and out of the way. All right, let's go ahead and start up on this section. So first of all, we're going to go over some cryptographic definitions, and these are going to be standard definitions that you probably want to know and get a little bit of idea of, and kind of take it from there. All right, so we have what's called cryptography. And cryptography is basically the science of hiding the meaning of communication. Right? We have a cipher, something that transforms characters or bits into an unreadable format, called a cipher. Cryptographic algorithm, which is the procedures that turns readable data into unreadable format. Today this takes place through the complex mathematical formulas, also doing that on the asymmetric side of things. We have cryptanalysis, which is the science of studying and breaking encryption mechanisms. These could either be white or black. Cryptology is the study of cryptography and cryptanalysis. Key clustering. This is when two keys generate the same ciphertext from the same plain text. Here we have the crypto system. Encompasses all of the necessary components for encryption and decryption, such as the software, the protocols used, the algorithms, the key lengths, And PGP here in this case is the pretty good privacy is just one example of the crypto system. Remember, we talked about PGP at least for a moment, and we generally see PGP when it comes to mail, emails and so forth. We talked about PGP for just a moment when we talked about whole disk encryption, but here is where we mostly see it during the actual email encryption type side of things. Plain text here is basically readable format, which gets decrypted, and ciphertext is the unreadable format, which is considered then encrypted, which is a long string of random values. We have an algorithm, which generally is going to be a group of mathematical equations that can be used for encryption and decryption process. And used together, the key values are then used by the algorithms to indicate which equations to use in what order and with what values. And we will need to know about a few of these. And again, it's just a matter of memorization of some of the different ones out there. So we'll make it easier on you here. We'll give you a little listing on some of the things that we're, again, talking about here. And you should be able to come across and get those memorized. So when it comes to symmetric cryptography, some of the things here we need to look at is that it uses two instances of the same key. So when it comes to symmetric cryptography, it's using the same key. One key is used for both encryption and decryption processes. The sender and receiver, guess what? They use the same key. Now with asymmetric, which we'll talk about separately again, it uses a key pair. It uses two mathematically related keys. Keys are always work as a pair. If one key is used to encrypt the message, the other half of the key pair must be used to decrypt the message. The key owner keeps the private key half of the key pair private and then can share the other half publicly. And a lot of your publicly available keys in this case are going to be like your certificates that you have in your browsers and so forth. Those are called public keys in a sense there. All right. Okay. Now, the types of ciphers that are used today, and this is where we get into some of the modern cryptography. We have different ways such as substitution methods that we can use, where we're basically substituting one bit for another bit type of thing. We have transposition methods, where bits are moved to a new place in the bit stream type of thing. We have symmetric ciphers, which we will need to know about these, some of the block ciphers and stream ciphers, and then, of course, asymmetric ciphers. So when it comes down to the encryption-decryption methods, again, we have substitution, which I mentioned, is one bit for another bit. Destination has to have the correct key to indicate how to substitute the original bit back in. And if you guys remember back in the day, was it the Christmas Story, right? Where you had that little ring that the boy was playing with, and you had the decoder ring, right, that he was using, something to that effect, right? We have the transposition, where the bits are moved to a new place in the bit stream. The bits are scrambled, and the new bits are introduced. Destination then has to have the correct key to indicate how to unscramble the bits. All right, now this is something you may want to write down and memorize a little bit, because knowing just the symmetric algorithms and which ones they are will definitely assist in answering questions correctly. So when we look at a symmetric cryptographic standard, out of these options here, obviously all of these are going to be part of that. Now we have what's called DES, your data encryption standard. We have triple DES, Blowfish, Twofish, IDEA, RC4, 5, and 6, and AES, your advanced encryption standard. And what you basically want to know here is that, that these are all symmetric algorithms. So if a simple question comes around, here are your 5 choices. Which one of these are symmetric algorithms? You should be able to identify those by just memorizing this little chart right here. All right, so do everything you can to get these few items memorized to answer those simple questions when it comes down to it. Very similar to what we saw earlier in some of the earlier modules regarding port numbers. Again, you may come across particulars that will basically talk about, what's DNS port number, and you need to know that it's port 53, right? NTP, port 123, Kerberos, port 88, right? Just little things like this that can really assist you in answering some of those questions correctly with the blink of an eye. Right, we have a type of semantic ciphers, block cipher here in this case, which is the message is divided into blocks and then put through a mathematical function. Each block is then encrypted separately, and the whole message is not encrypted as one entity, however, so the best used in software implementations and such. Also, of course, your whole disk encryption and so forth along with that as well. So some of the advanced standards algorithm used is going to be bulk data encryption when it comes down to that as well. All right. Now, other things that we have here is the stream cipher, and it encrypts individual bits of the message, not blocks of the data. So one bit of the key stream is XORed, which we mentioned, right? The exclusive OR, with a bit from the message. The stream algorithms have a key stream generators, which creates the bits that are XORed to message bits. More complex when it comes to proper implementation compared to block ciphers, and it's best used in hardware implementations. Some of the downfalls that we have when it comes to symmetric is the key distribution. So it requires a secure method to get the key into the destination, right? Because once the key gets compromised, guess what? Poof, we actually have the ability to decrypt the message since we're using the same key to encrypt and decrypt the message, right? So keep that in mind there as that comes about. Now another issue is scalability, where each pair of users need a unique pair of keys, so the number of keys can grow and become unmanageable generally. Limited security, so it can only provide confidentiality but not true authenticity and non-repudiation, again, because if the key gets compromised, woof. However, there is a solution to that which we'll talk about here in just a moment. So when it comes to symmetric ciphers that we're going to look into, again here we're going to look into some of these individually, and I'll mention a few things that we'll need to know there as well. All right, so we'll take a look at DES, triple DES, AES, and so forth. So here, let's take a look at the data encryption standard, your DES. Obviously, everything here is going to be important. We need to know that DES is a block cipher. It's used to protect sensitive but unclassified data. IBM submitted their Lucifer algorithm for the NIST DES standard in 1974, and they have modified it to have a 64-bit key, which 56 bits make up the true key and 8 bits are used for parity. Data blocks of 64 bits are put through a 16 round of mathematical procedures for encryption and decryption purposes. Then we came up with triple DES. Now, triple DES in the 1990s, they came out with a DES cracker machine that was built to recover the DES key in a few hours. Performance hit because of the extra processing. Now, it provides more protection by providing 3 rounds of encryption, and this can take place in 2 or 3 different keys depending on the mode. We have DES EEE3, which uses 3 keys for encryption, DES EDE3, which uses 3 different keys, encrypts, decrypts, and then encrypts the data. We have DES EEE2 and DES EDE2, which are the same as the previous mode, but the first and third operations, in this case, use the same key. Now, you don't need to know about the DES EEE3 and the EDE3 differences, but what you do need to know is that a triple DES, as in 3 DES, is a symmetric cryptographic standard. That's definitely something you need to know. And also remember, of course, regarding block ciphers versus stream ciphers, the difference thereof as well, and that will assist in that process too. AES, your Advanced Encryption Standard. This is a replacement for DES. It's obviously a block cipher, block symmetric encryption algorithm. The U.S. official standard for sensitive but unclassified data encryption. It uses what's called the Rindal algorithm, and the key sizes are 128, 192, and 256 bits. In general, whenever you talk about AES encryption and so forth, it's generally going to be 128 as a standard. Okay, now, as I mentioned too, what was else was 128? We had the MD5 hashes, which were 128. We also talked about the sys key. Remember when we talked about that earlier? When the sys key protects the SAM database, it was also at 128 bits. Right? We talked about MD5 hash algorithms for used for NTLM version 2. This is also MD5, 128-bit. And that's where all that kind of comes into play. And as you can notice here, as we go through, you'll be able to identify a few of those questions by just knowing, again, just a little piece of information that will assist you in the overall goal of getting those answers correct. Now, other symmetric algorithms is IDEA, which is a block cipher. It operates on 64-bit blocks of data. Its key length is 128 bits and uses 8 rounds of 16-bit subblocks. We have RC5, and RC5 is block sizes of 32, 64, and 128. It rounds up to 255, and the key sizes are up to 2048 bits. Now there is another thing called RC4, which is generally going to be used for voice and video when it comes to bidirectional type stuff. So it's called RC4. That will be probably the only time we're going to mention that. But needless to say, RC5, again, block size we covered, key sizes and so forth. We also have 2FISH, which is block cipher, 128-bit blocks in 16 rounds, and the key sizes up to 256 bits. Let's mention real quick some of the characteristics of hash algorithms. Accepts variable length strings, messages, as in the say, and generates a fixed length value. It's called a hash value. Again, important part here is that it's fixed length. No key is required or is involved here. No confidentiality is provided because nothing's getting encrypted. It's similar to what we call the cyclic redundancy check function, the CRC. Right? It creates a fingerprint of the message. And this can, again, be done through for a hard drive, for a file, whatever the case. And the ones that we've talked about, of course, are going to be your Message Digest 5, which runs at 128-bit, and your SHA-1, which is your secure hashing algorithm one, which runs at 160-bit. And those are mainly what we need to know there when it comes down to the hashing algorithms. And again, the output of 160 versus 128. When it comes down to some of that. And that's the main thing they focus on generally when it comes to that. But MD5 is also the default password hash algorithm used by NTLM version 2 as well. All right, so what do we have here? Hashing algorithm sender. The message is put through the hash algorithm. The results is a message digest value. The message digest value is attached to the message and then sent to the receiver. Hash algorithm on the receiver side, the message is put through the same hash algorithm. The results is an independent message digest value. The receiver compares those two values, and if they're the same, the receiver is assured that the message has not been modified. If they're not the same, the receiver then discards the message. And here we can see kind of the hash algorithms there. Again, the most important ones are going to be MD5 and SHA-1. Of course, there are other ones out there as well, but needless to say, 128 and 160 are some good numbers to know. All right, now let's pop into the asymmetric side of things. And also, we'll mention PKI, which is your public key infrastructure. So when it comes to the asymmetric key system characteristics, it's also called the public key cryptography, also known as Diffie-Hellman. It basically uses two different keys. We have a public key and a private key. The public key can be given to anyone, and the private key is then possessed only by one owner. Public and private keys are mathematically related but should not be able to be derived from each other, so that way if one gets caught, the other one can't be derived from it. The keys have dual natures, which can encrypt and decrypt. The data encrypted with the public key can only be decrypted by the corresponding private key, the same as the data encrypted with the private key can only be decrypted by the corresponding public key. Again, here's another one that we need to write down and memorize a little bit. And when it comes down to the algorithms that are used, again, one's called Diffie-Hellman, and that's going to be a given. So anytime you hear Diffie-Hellman, we're talking about asymmetric. We have El-Gamal and the ecliptic curve cryptosystem, also known as ECC, and these are known as asymmetric algorithms. All right, so here we have the Diffie-Hellman. It basically came upon a key agreement protocol, the agreement on the symmetric session key that will be used for encryption process. This does not require a previous relationship between the two parties needing to communicate, which allows the key arrangement to happen in a secure manner. And security based on calculating discrete logarithms in a finite field. It is vulnerable to man-in-the-middle attacks because it has lack of authentication, and it does not provide data encryption or digital signature capabilities. And here we have Whitfield Diffie and Martin Hellman, such as the Diffie-Hellman, which are the authors of the first published paper on public key cryptography.